What's up, guys? Mr. Hausman here. Today we're going to be covering compound interest, right? So we're going to be dealing with some money. Right? And just to get started, let's go over some vocabulary just so we know what we're talking about, right? And some things we got to know are interest, which is the money paid for the use of money. Right? We need to know principal, which is the initial amount of a loan or savings plan. The rate of interest, or interest rate, is the amount charged for the use of principal of a given period of time, expressed as a percent, but changed to a decimal in form. There's a payment period, which is the number of times per year that interest is calculated. Right, so when we're talking about interest, we're mainly talking about kind of things as in like loans or different types of accounts you can get at a bank have an interest rate where you can deposit money and then that money will kind of grow with that interest rate. Or maybe you take out a mortgage on your house, right? So you get a loan from the bank and then they charge you interest for how long you use their money, right? So the payment periods and how we kind of determine them is there's really four ones we should be worried about, right? Annually means that it is calculated one time a year. Semi-annually is 2 times a year. Quarterly means that it's 4 times a year. And then monthly would just be 12 times a year. Right, so there's also different kinds of interest. One that we'll start with is just simple interest. And we've probably seen this equation before. Right? It's interest calculated just once, only based on the principal amount deposited. So there's a formula we can use for it, and it's I equals PRT, which is the interest is equal to the principal times the rate times the time. Right? But what we're really going to be talking about today is compound interest. And what that is that's interest that is calculated on the original principal plus other interest that has been accrued. Right, so we have a formula here, right? And it's the formula we're going to use anytime we talk about compound interest. Right? And it's the future amount A after T years due to the principal P invested at an annual interest rate R compounded N times per year. Right? And I know there's a lot of variables in this, but when we kind of break it down, it gets a lot simpler, right? So A here is just how much money that loan or maybe that bank account is going to have after the amount of time, which is T in years, due to the principal P, which is how much was initially invested. And then it's using R, which is the interest rate, and however many times it's compounded, we write that as our N. All right, so let's look at a problem, and it'll probably get a lot more clear, right? For number one here, it says $300 invested at 12% compounded monthly after a period of 1.5 years. All right, so we're trying to find out how much resulted from the investment. Right, so maybe we're starting a new bank account, right, and we're investing $300. Right, so that's going to be our principal. So we can write that as our P, right? P equals 300. It's invested at 12%. Well, right there, that's our rate, which we can write as R. But we can't write it as just 12. Remember, we have to convert it to decimal form. But it's super easy. All we have to do is just move the decimal to the left twice. So we get 0.12. Right. It's compounded monthly. And if we remember from our definition here, monthly means it's going to be compounded 12 times. So that's our N, which we can write as 12. And then it's after a period of 1.5 years. So the time is 1.5. Right? And it's always good to write out our values here, because once we have them written out, all we have to do are plug them into our compound interest formula equation, right? A, which is the value we're solving for, is equal to the principal, which is 300, times 1 plus r over t, so 0.12 over 12. Right, and that's all raised to the n times t, which is 12 times 1.5. So we can say raised to the 12 times 1.5. All right, and then all we have to do is kind of plug that into our calculator. All right, so we got to deal with the parentheses first. So we can say 1 plus 0.12 divided by 12, and that's equal to 1.01. Right, we can raise that to the 12 times 1.5. Right, and notice how I'm putting parentheses around this 12 times 1.5. What that's saying is that this 1.01 is being raised by 12 times 1.5. If I didn't put the parentheses, and I can even show you guys. Right, if I just did this, this would be 1.01 raised to the 12, and then after you do that, it would multiply whatever that answer is by 1.5. But that's not what we're looking for, right? We got to make sure we put parentheses around it so that our calculator knows what we're doing, right? All right, so now we have all of this figured out. We just have to multiply by 300. And we end up getting $358.84. $358.84. All right, so let's look at another example here. This time, we know our A value, right? We're trying to get to $300. So A in this case is 300. Right? We're trying to find the principal. So we're solving for P in this one. It's given that our time is going to be 4 years, right? So T equals 4. It's at 3%, so our rate is 0.03, and it's compounded daily. All right, so what we can do, that means that our N is going to be 365, right? Because it's being compounded every day, and there's 365 days in a year. Right? So now all we have to do is plug that into our equation. Right? We know A is 300. That's going to be equal to the principal, which we're trying to solve for, that's P, times 1 plus rate over time, so 0.03. Or sorry, not rate over time, but rate over the number of times it's being compounded, so 0.03 over 365. And that's all raised to the n times t, which is 365. And we'll kind of write it like this. T is 4. All right, so what we can do is we can actually rewrite this by dividing all of this over. All right, so we can kind of rewrite it like this. This would be P equals 300 all over, because all we're doing is we're taking all of this parentheses here, we're dividing it to the other side. So it would be 1 plus 0.03 all over 365, all raised to the 365 times 4. All right, so now that we have this, again, we can just plug this into our calculator, right? And we'll start with the parentheses just like we did last time. All right, so we got 1 plus 0.03 divided by 365. All right, that's going to be raised to the 365 times 4. And then what we're going to do is we're going to do 300 divided by our answer, which to get answer, you just hit second and then the negative sign at the bottom. And when we do that, we get our principal would have to be 266.08. Remember, when we're dealing with money, we always round to the hundredths. All right, so last example on this page. Which of the two rates would yield a larger amount in 1 year? 8% compounded semi-annually or 7.9% compounded daily, right? So let's just compare these two separately. In our first example here, right, we have the rate is 0.08, and it's compounded semi-annually, which is just 2 times a year. All right, so if we want to know how much it would yield, we can kind of just use the variables for the other values and see what we get. We have 1 plus 0.08 all over 2, and that's raised to the, it says right here in the instructions we have 1 year. So for both of these, t is going to be equal to 1. Right, so this is going to be raised to the 2 times 1. Right, now we can't do anything with a and we can't do anything with b, but we can solve all of this right here, right? So we can say 1 plus 0.08 divided by 2 equals all raised to the 2 times 1, which is just 2, but and we get 1.0816. So this is going to be a is equal to p times 1.0816. And this is really the number we're looking for, right? Because we want to know how much, or which rate, I should say, is going to bring a larger yield. Well, this is going to be principal times this number is going to give us our yield, right? So whichever one has the larger multiplier is going to be the one that has the larger yield. So now all we have to do is kind of compare our second one, which has a rate of 7.9. Right, so our R is 0.079. It's compounded daily, right? So that's going to be n equals 365. And it's got the same time, right? T equals 1. So again, we can just plug that into our equation. We have A equals P times 1 plus the rate, which is 0.079, over the number of times it's compounded, which is 365, all raised to the 365 times 1. All right, so again, we just plug it into our calculator here. Right here we have 1 plus 0.079 divided by 365. And that's all raised to the 365. All right, so in this one we get A equals P times 1.082195071, right? And we'll just write it all out. Right, but right away we can see, okay, this number here is larger than this 1.0816. Right? It's similar until we get to this thousands place, right? This is a 1, this is a 2. Right, so we know, oh, this is the larger multiplier. So 7.9% compounded daily is going to be our answer for this one. All right, so let's keep going. A couple more examples on the back, right? Now, there's another type of interest that we can calculate. And what it is, it's a continuously compounding interest. It's interest calculated infinitely many times per year, right? So in the other ones, it gave us that it was compounded annually, which is 1 time a year, semi-annually, which is twice a year, right? Or daily, which is 365 times a year. Right, but in this one, it's a special case because it's being calculated infinitely many times, right? So we don't have an n. N is infinity, right? So there's a different formula we use for this one, and it's A equals P times E to the RT. So we've seen E a few times now. This is one of the equations where E really comes in handy, right? So Let's look at an example. Find the principal needed now to get the desired future amount. That is, find the present value. Right, so this time we're trying to get 800 after 2.5 years at 8% compounded continuously, right? And here's the key word here, continuously. Whenever we see that, we should know, oh, we're going to be using our continuous compounding interest formula, right? Which is that A equals P times E to the RT. Right, so we're trying to get 800. That's going to be our A, right? Because we're trying to find the principal. The time is 2.5 because we have 2.5 years, and the rate is 0.08. Right, so all we have to do is plug this into our equation here. A is 800. Principal is what we're trying to solve for. E is just our constant here, and that's raised to the 0.08 times t, which is 2.5. All right, so again, we can just divide this e over, right, and we're going to get p is equal to 800 divided by e, all raised to the 0.08, and we'll rewrite it as this, times 2.5. All right, so I can just plug that into our calculator just like we've been doing. 800 divided by e raised to the 0.08 times 2.5. All right, I got to make sure I close all my parentheses. And what I end up getting is that the principal then is going to be $654.98. Let's keep going. We got 2 more examples. How many years will it take for an initial investment of 25,000 to grow to 80,000? Assume a rate of interest of 7% compounded continuously. Right, so here it gave us the principal, the initial investment is 25,000. Right, it's growing to, which is our A value, 80,000. The rate is 7%, which is 0.07, and we're compounded continuously, right? So we know we're going to be using the equation A equals P to the E R T. Right, so let's plug in our values, right? We know A is 80,000, P is 25,000, E is just our constant E, the rate is 0.07, and we're trying to solve for T. Right, which gets a little tricky, right? Because t is in the exponent. But what we can do first is we can divide this 25,000. Right, so we just got to do 80,000 divided by 25,000. And we actually end up just getting 3.2. And that's going to be equal to this e to the 0.07 times t. Right, and if we remember kind of what we've been talking about the past couple of days, we can use logarithms to solve this problem. Right, what we can do is transform this into our log form, right, and say log base e of 3.2 is equal to our exponent, which is 0.07 times t. Right, and if we remember log base e, that's just the same thing as the natural log of 3.2. All right, so now all we have to do is plug in that natural log of 3.2 and then divide this 0.07 over. And we end up getting that the time is about 16.62 years. Right. Last one here, last one. On January 1st, Kim places 1,000 in a certificate of deposit that pays 8.9% compounded continuously and matures in 3 months. Then she places 1,000 and the interest in a savings account that pays 5.25 compounded monthly. Notice how that's not continuously, right? How much does Kim have in the savings account on May 1st, right? So the first thing we have to do is we have to figure out how much she has in the certificate of deposit, right? So on January 1st, right, the principal is 1,000, right? The rate is 0.068, right? It's compounded continuously, and she's only leaving it there for 3 months, right? And if you think about 3 months, what we have to remember is that the time always has to be in years, right? So 3 months out of 12 in a year, well, that's just a quarter, which is 0.25. Right, so now that we have these values, we can figure out how much was made in this account, right? A equals P to the E RT, because remember, it's continuously, so we have to use our continuous formula. And we just plug in our values, 1,000 to the E raised to the rate, which is 0.068, times our time, which is 0.25. Right, we plug that into our calculator. We have 1,000 times E raised to the 0.068 times 0.25. And we get 1,017 and 0.14. Or 1.5, sorry. All right, so that's how much she made in the certificate of deposit. Right now, she's going to take that. Right, she places the 1,000 and the interest in a savings account. So she's taking how much she made and she's going to put it as the principal in the next account. Right, so in this one, it's compounded monthly. So we're going to use our other equation, right? A equals P times 1 plus R over N to the T N. Right, in this case, the rate is 0.0525. Right? The time we'll get to in just a second, but it's compounded monthly, right? Which means it's going to compound 12 times. Right? How much does Kim have in the savings account on May 1st? Right? And here's where we got to think, okay? From January, she matured it for 3 months, right? So January, February, March, April, right? So this account's starting in April, right? April 1st, April Fool's Day. And it's going to May 1st, right? Well, that's a total of 1 month, right? So time in this case is just 1 out of 12 because it's only going for 1 month out of 12 in the year. All right, so now that we have all this, all we have to do is plug it into our equation. We have 1017.15 times 1 plus 0.0525 all over n, which is 12. And that's all raised to the 1/12 times 12. All right, so we plug it into our calculator. 1 plus 0.0525 divided by 12. And that's all raised to the 1/12 times 12. Right? Well, 1/12 times 12, that's just 1, right? And anything raised to the 1 power is just itself. So all we have to do then is just multiply by 1017.15. And we end up getting that the amount earned is 1021.60. All right, thanks for listening, guys. Have a great rest of your day.